Hello everyone, my name is Yulin. Today I'm going to introduce our attention-based spatial guidance image-to-image translation framework. In this presentation, I will first introduce the problem setting, then I will summarize the typical existing solutions and their limitations. I will then discuss our proposed solution with details. Finally, we conclude the current limitation and future work. Lots of computer vision tasks can be recognized as an image-to-image translation problem. For example, image super resolution, coloralization, still translation, and etc. Recently, with the rapid advance of GAN framework, the generator and discriminator structure is widely used. Here are two representative GAN frameworks. One crucial drawback of GAN framework is that the discriminator is typically much stronger than the generator. Several problems are caused by it, for instance, model collapse and validation gradient. All those problems make the GAN framework hard to train and sensitive to the hyperparameter. The motivation of our method are based on a closed-loop feedback control system. We would like to borrow some power from the discriminator. As we can see in the plot, our approach forces the discriminator to provide explicit signals on the mistake regions of the generated image. Comparing to a typical GAN framework, our framework contains an extra attention transfer block, which computes the attention map of a given image. Our framework can deal with supervised translation by using L1 or L2 regularization, which can be seen in the bottom left of the image. Our solution also works in an unsupervised setting by applying the cycle-consistent constraint, as we can see in the right part of the image. We then show that how we generate the attention map and how we mix them with the original input. We adopted two attention mechanisms. The left one is called post-hoc attention, which is computed by the activation of the force convolutional layer. We have trainable attention module on the right, which not only provides an attention map, but also enhances the power of the discriminator. We then propose two concatenation methods to combine the attention map and the raw inputs. One is called alpha concatenation, which is simply adding an extra challenge to the image. The second strategy follows the same workflow of the trainable attention module, namely, we compute the residual hard mode production between the attention map and the original input. We evaluate the proposed approach on three real-world image datasets, image subcategories like horse to zebra. We also use a collection of sampled and cropped image from BDD 100K that is called day to night. Lastly, we use Cityscapes for the supervised setting. To verify the effectiveness of the proposed method, we compared it with several state-of-the-art solutions for image translation. For unsupervised translation, we adopt kernel inception distance as a performance metric. For unsupervised translation, FCN score are used for the performance measurement. We first show the quantitative performance over apple to orange and summer to winter on the different combination of the attention mechanism and concatenation method. We then provide the numerical target KID and fused KID in different combination. Based on the performance, we use post-hoc attention in later experiments. In this slide, we show the performance of a competing method in each task. Our method outperforms baselines by providing higher target KID for objective-oriented tasks and higher fused KID for scene-oriented tasks. We then provide the FCN score on the Cityscapes dataset. We observe that our method got improvements over the baselines, although the improvement of supervised translation is limited. Some qualitative results are presented in this slide for object translation. Please note that although our framework changed the background, we perform better on the object itself. And for scene translation tasks, we generally outperform the baselines. There are two limitations of our method. The first one is the improvement over supervised translation is limited. The second one is the performance of our framework is sensitive to the selection of attention module. For the future work, we are planning to investigate the impact of different attention mechanisms, like the visual transformer. Thank you very much.